In this section, we're going to continue with confidence interval, but instead of estimating our population mean mu, we're going to estimate the population proportion p. But it's still going to be the same idea because we're still going to need two things, a point estimate and a margin of error. And this section is actually going to be a little bit similar to section 7.1 because our population is going to follow a standard normal curve. So we could use our z values to find our critical values. So that's going to be a little bit easier. So here, to estimate our population proportion p, we could use something called a point estimate. And again, a point estimate is a single number that is used to estimate the value of an unknown parameter. In this case, the point estimate for our population proportion p is going to be p hat. And in this case, this is going to be our sample proportion. Our sample proportion. And how do I compute this p hat? Well, it's just going to be x over n, where n is going to be our sample size, and x is the number of individual in the sample that we kind of care about. So here, for example, here's a couple notation that we should probably get used to. P, without the hat, so just P, is the population proportion of individuals who are in a specific category. X is the number of individual in the sample who are in the specific category or that we care about. N is just going to be our sample size, and p hat is the sample proportion. And again, p hat is just x over n. Now, how do I compute these confidence intervals? Well, just like what we're talking about for this whole chapter, we have to consider some of the requirements. So before even beginning to compute a confidence interval, we have to check that all of these are satisfied. We have to see if our data comes from a simple random sample, and usually it does. The population is at least 20 times as large as the sample. The item in the population are divided into two categories, and the sample must contain at least 10 individuals in each categories. If all of these are satisfied, then we can continue in computing our confidence intervals. But how do we construct our confidence intervals with proportion? Well, it's going to be very similar what we've been doing with the previous sections. First, we have to compute our sample proportion, p hat, and if you remember, this is just going to be x over n. Then we want to find our critical value. Since we're working with a standard normal curve now, we could just look at a table and see which confidence level corresponds with our critical value. Then we want to compute our standard error here. And this is going to be a little bit different. So our standard error here, the formula for it should be the square root of p hat times 1 minus p hat over n. And again, p hat is just x over n. And it's also called our sample proportion. And n here is just our sample size. So just a little reminder. Now that we have our critical value and our standard error, we can compute our margin of error. And again, we just call this E, just to make it a little bit easier. So E is going to be our critical value times our standard error. So once we have our margin of error, and remember, that's the key thing with computing confidence interval, is we just need two things, a point estimate and a margin of error. So we use our point estimate p hat and the margin of error to construct our confidence interval. So this is going to be p hat minus E is less than, and since we're not estimating our population mean, we're estimating our population proportion. That's why we have p here instead of mu. So mu is going to be between p hat minus E and p hat plus E. And again, the most important thing, the last step, and probably the most important step, is we have to give the interpretation. And we could say something like, we are some sort of confidence level, like 95% confident that the proportion parameter is between these two values. And again, this is gonna change depending on what problem you're working with, because each problem is gonna be like you have to tailor this to each problem. Now let's do an example. So here, in a survey of 517 music teacher, 403 of them said that video games like Guitar Hero and Rock Band have a positive effect on music education. The goal here is to construct a 95% confident interval for the proportion of music teachers who believe that these video games have a positive effect. So here, we only care about the proportion of teachers who believe that these video games have a positive effect. First thing we want to do is we want to compute our point estimate, p hat. And again, p hat is just going to be x over n. Since we only care about the proportion of teacher who believes that these video games have a positive effect, we know that our sample size here, they survey 517 music teacher. So our sample size is 517. And we know that out of those 517, 403 of them said that video games like Guitar Hero and Rock Band has a positive effect on music education. So here, this gives us an idea that x is 403. 403. So our p hat, our point estimate, is going to be 403 all over 517. And this is going to be 0.779497. Next, we want to find our critical value. In this case, we want to find our z of alpha over 2. And the great thing about this is that we can actually just look it up in our table. If you look at our table here, if you go down to, oops, let me just erase this real quick. If we go down to a 95% confidence level, we could find the corresponding critical value, our z value, of 1.960. And since this is a standard normal curve, we could use the z value. So this is going to be just 1.960 or just 1.96. Next, we want to compute our margin of error. And again, this is just going to be our E. And if you remember from our notes here, our margin of error, it's just going to be our critical value times our standard error. So this is going to be equal to z of alpha over 2 times the square root of p hat times 1 minus p hat all over n. Do we know our critical value? Yes, we do. Do we know our p hat? Yes. And we know our sample size, which is 517. So now we're able to compute our margin of error. So this is going to be 1.96 times the square root of 0.779497 times 1 minus 0.77949497 all over 517, and this value will be 0.035738. Now we're able to construct our confidence interval, and this is just going to be p hat minus e is less than our population proportion p less than p hat plus e. So this is just saying that our population proportion is between these two values. And I'm just gonna skip the math here and just tell you the value is gonna be, you should be getting 0.744 is less than p is less than 0.815. And this is our 95% confident interval. But the last step is that we have to interpret our result. If we're not able to interpret, if we're able to compute all this, but we're not able to know what it means, then there's not a lot of value behind it. So we have to be able to interpret our result. So we could say something like, we are 95% confident that the proportion of music teachers who believe that video games have a positive effect is between 0.744 and 0.815. Now notice that my interpretation, I'm kind of tailoring it into what the problem is asking, because we only care about the proportion of music teachers who believe that these video games have a positive effect, and that's what I wrote here. Last thing I want to talk about is that we're able to actually estimate or compute the sample size that's needed in order for a study to have a certain margin of error. So for here, for example, let m be the desired margin of error, and let z of alpha over 2 be the critical value. So this is just the critical value. The sample size n needed so that the confidence interval for a proportion will have a margin of error that's equal to m is with these formulas. So this is the formula that we need if we know the value of p hat, or our sample proportion. If we don't know this value, then we will use this formula instead. And again, this is just going to be if we don't know the value for p hat or our sample proportion. And let's say n was like a decimal, then we always round up. So for example, let's see, from the previous example, and describe a sample of 517 music teacher, 403 of them believe that video games has a positive effect on music education. And here they're asking to estimate the sample size needed so that a 95 confident interval will have a margin of error of 0.03. So here they're asking, like, what is our sample size that's big enough to have a margin of error equal to this value here. So that's the goal for this question. So here, m, the margin error that we care about, it's going to be 0.03. And our sample proportion is going to be the same from the previous example, which is going to be 403 over 517. And this is going to be 0.7799497. our z-value, sorry, not our z-value, our critical value for a 95% confident interval is going to be z of alpha over 2, it's going to be 1.96. So our formula that we're going to use here is going to be this formula here. So it's going to be n is equal to p hat times 1 minus p hat z, our critical value, over our margin of error square. Since we already know all these values, all we have to do is plug in our values in and then compute our sample size. So this will be equal to 0.779497 times 1 minus 0.779497 times 1.96 divided by 0.03 square. And if you put this in your calculator, this is just going to be equal to 733.67. But since this is a decimal, we can't have a sample size of 733.67 people because we can't really cut people in half. So that's why we always round up. So this is going to be 734. So the sample size needed in order to have a margin of error of this value, they're going to need about 734 people.